if you are, if you have questions, you can just type them in the chat or you can unmute. And then if you didn't see already, I already recorded and posted the YouTube video or posted onto YouTube the videos or the reviews that I did on Tuesday. I haven't uploaded the one I did today at noon, but I will upload that as soon as either tonight or most likely tomorrow. It'll get uploaded. So flow rate, to keep it simple, flow rate is a new thing, but you've seen it before because I know you've done some rotations. You've been in the hospital setting where you've seen people on an infusion pump, and you could see that what it's programmed to. If you paid attention to it, you probably saw it was like 300 milliliters per hour or whatever it happened to be for whatever they on. You may have even paid attention to what was being infused. Was it normal saline? Was it a dextrose solution? Was it a medication being administered? There's a variety of different things. So to keep it simple, we're just going to use this example where they're infusing Ringer's lactate, 400 milliliters, and they want it in the patient over a period of 2 hours. And so when you calculate a flow rate, first of all, to define flow rate just means flow rate is you have some sort of volume over a period of time. And typically in nursing, that volume is going to be milliliters and that time is going to be hours. So when we look for and calculate a flow rate, it's ml per hour. So to solve this question, I'm just going to take the 400 milliliters over 2 hours, and I'm going to reduce. And that will reduce to 200 milliliters per hour. Believe it or not, this is a commonly missed question because students are often looking for more things to do. This is it. There is nothing more to do. You're doing it. It's just the 400 over 2, reduce it. So just put in your calculator 400 divided by 2, and then now you have your milliliters per hour. So
It's done. And Doc, the hour, are they going to put it in 60 minutes or just leave it like that?
So when you're calculating flow rate, you want to calculate ml per hour, and it even tells you in the question. So the calculate ml per hour.
Thank you. And you said something about the YouTube. Is it the YouTube? Is it where can we get it? This is my first time. Is it supposed to be my Blackboard or?
It would be like when they sent you the link of when I am doing my reviews. It gives you the Zoom link, and then there's the link for the practice tests or practice review problems, and then there's the link for my YouTube channel. But I will put my email in the chat, and if you didn't get any of that, just email me and I'll make sure I get it to you.
Okay, thank you.
You're welcome. So what I'm going to ask you to do, that those of you that are here, go ahead and try and answer. We'll just call these, we'll say this is A, this is B, and this is C. And then see if you can answer B and C. We already answered A. And I'm going to fix the letters here in just a second. Sorry, it's being a pain. Okay, so yeah, go ahead and solve for B and C, and then just put your answers in the chat. I made them intentionally tricky because I'm trying to see if you can figure out how to do these two. So go ahead and once you get an answer, just you could send it as a direct message, or you could just answer to everyone, and then I'll confirm once we get everyone's answer in. Okay, so by sheer luck, every single answer is the same. Each one of these is 200 milliliters per hour. So if you were getting that and going, is this right? It is correct. So let's work through B and C just to make sure we're all on the same page. So for B, you're going to take the volume. This time it's 150 milliliters over your time, 45 minutes. And you need to convert minutes to hours. So you can do this any number of ways. If you know that, if you want to say this is 0.75, because you know that's 3/4 of an hour, that's fine. Some people like to do that. But if you're like me, you don't trust that fading knowledge from grade school. And so you just do 150 times 60 divided by 45, and then you're going to get the same answer as you got before. It's just that we use different numbers. So that was if you were on here when I started this, you saw that I was editing these. That was purely by chance. So that was not intentional. And then letter C, the biggest thing is you got to remember that 1.5 liters is the same thing as 1,500 milliliters. And then you just 7.5 hours. And again, you get, after you reduce it, you get the same answer, that 200 mil per hour. So again, that was not intentional. It just happened to work out that way. So yeah, okay. Now, in the earlier session, I had some questions about the drop rates. And so I ended up focusing on that as well. So like when you come back to this and you'll have access to the 24, it's labeled as 24 Fall Nursing 130 review. So you'll see my edits. You'll see all the different questions. You should be able to download the Word document and delete like if you just select it with your mouse and just delete it, you should be able to if you want to, practice it fresh. And then if I remember, I'll go through and I'll create a blank one, but I'm constantly changing these, which is why I haven't done that. So I did a few of these drop factor questions and I made some additional drop factor questions. So I'm going to go through this initial one and then give you the practice with the other ones. So just give me a second. Let me just clear out some stuff here. So like I said, I'm focusing on the things that are new, things that you haven't seen yet that'll be worth reviewing. And then if you need to see it reviewed again, I'm recording these. You can rewatch the recordings. You can watch them for previous things. And then what I'm going to do is I'm just going to clear out some of these things here. In case you decide to try these. I might even change them just so we have a different variation here. Just bear with me. That way we can get some additional practice. All right. So the next evolution of flow rate is our drop rate. So drop rate is a type of flow rate, but we're getting a different rate. And in this rate, what we're looking for is drops per minute. And the way that they abbreviate drops is GTT. Okay. So you'll see that abbreviated here. It says GTT per minute. That just tells you what you're looking for and that it is in drops per minute. And we'll do this a couple different ways to get to a satisfactory answer. Or you'll see a variety of different ways in which this is asked, but you need only two pieces of information to solve these flow rate questions, drop rate questions. You need flow rate and you need your drop factor. Those two pieces of information will equal your drop rate. Now your flow rate is typically milliliters per hour, but sometimes it can be milliliters per minute. Your drop factor will always be given to you, and it's drops per milliliter. So in case you get it just says drop factor is 10, you know now that whenever they say that, they mean 10 drops per milliliter. That's what the drop factor is. And every drop factor, every tubing has a unique drop factor to it, and so it has to be labeled, and it's based off of the diameter of the tubing, I'm assuming. And your drop rate is always going to be drops per minute. Now, sometimes what gets frustrating is you'll get a flow rate question, and it'll say something like calculate the drip rate, but there will be no drop factor. And you would then, if there's no drop factor, then you're going to still solve for the flow rate in milliliters per hour. And the reason they can call that a drop rate is like, let's say it came out to being like 15 milliliters per hour. Well, 15 milliliters per hour is actually at a very slow drip. That's 1 tablespoon in an hour. So just imagine how slow you have to be dripping that out to get it to just drop out over an hour's worth of time. So the way to kind of alleviate any confusion associated with that, just if it has the drop factor listed or it tells you to look at the drop factor on the label, that's how you know you're calculating drops per minute. Also, a lot of times the question will say, what is the flow rate in drops per minute? So that's another way to figure that out. So the tubing tells you very boldly that it's 10 drops per milliliter. And so the rest of it is just figuring out the flow rate, figuring out the flow rate and then getting to the drop rate. So we look at the question. It says the physician ordered 500 cc's of dextrose 5% normal saline to be infused over 1.5 hours. If your tubing is labeled as below 10, what will the flow rate be in drops per minute? So if you are a dimensional analysis fanatic, this is where you really kind of get a chance to shine, because you're like, oh, all right. We got some dimensional analysis to do. If you really like to do ordered over available or desired over have, you're really going to have a hard time with some of these because they just don't pair up that way, because you don't necessarily have an order, you just have a flow rate. What are you setting the infusion rate to? Okay. And so it's just about manipulating volume and time, and the volumes change. Sometimes it's units, sometimes it's milliliters, sometimes it's cc, and sometimes it's drops. And so you just have to be, the best way to get comfortable with it is just to practice and then practice again, and then like 10 more times. And then that's what I try and do by giving you lots and lots of examples and walking you through them. So this flow rates, we're going to take our volume, 500, over our time, 1.5 hours. We're going to multiply by our drop factor, which is 10. CCs and MLs are equivalents, so you can cancel those out. Now, I inadvertently put a equal sign here. If I left this as it was, I would be in drops per hour, and you don't want drops per hour. So you need to convert hours to minutes. And then once you do that, you can get your answer that you're looking for. As a shortcut, you may have seen that I previously had written on here, you could also just not estimate, but 1.5 hours is the same thing as 90 minutes. So you can just, instead of putting 500 cc's over 1.5 hours, you could just go right to the minutes. You could just say 500 cc's over 90 minutes times your drop factor. And guess what? You have one less thing to write for your conversion. But if you want to be extra cautious, make sure you write that all in there. But either way you do it, you'll get to the same answer. So I'm going to do the bottom one. So 500 times 10 divided by 90. It's going to give me 55.55555555555. But it just keeps on going. So 55.555, and it just keeps on going. Now, unlike milliliters, you cannot give a partial drop. The patient either gets a drop or it doesn't drop. So when it comes to drops, we're introducing a new rounding rule. The new rounding rule is drops are rounded to the nearest whole number. So if this is 55.55, you look at the tenths place, it says 5. If it's 5 or greater, you're going to round up. And if it's 4 or fewer, you're going to leave it alone. You won't round it up. So for this one, we're going to round this to 56 drops per minute. So as a challenge, especially if you weren't here this morning, I'm going to, or earlier today, here are 2 more. So A and B. So I'll leave this up here so you can kind of see my flow. Go ahead and get an answer for A and B, and then we'll come down to C. See if you get the same answer I get, and we'll go over it together. So take a moment, answer A, answer B, put your answer into the chat, and then we'll go from there. Okay. So I'm getting some answers in. We got the first one. See if you got the same thing I got. 150 drops per minute. And the second one, 83. Now, if you got 83.333333333, that is correct. But remember, we round to the nearest whole drop. All right, let's do one more. Go ahead and do letter C, and let me know what you get. Good. So you should have gotten 200 drops per minute. All right. So we covered flow rates, we covered drop rates. The next thing to look at is an example of a 2-step problem.
Excuse me.
Yes.
How do you get the 200? Because maybe I made a mistake of that one.
All right. Well, tell me what you did. And you can either tell me, or you can just you can even just type your order.
I unmute myself now. I said 150
Mm-hmm.
divided by 15 minutes times 10. The, 20. Oh,
There you go.
I see my mistake. I was still looking at the other picture, the giving 10s. Okay.
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 All right. Now, yeah, so you set it up perfectly. I had a feeling and that's what I want you to, that's why I asked you to do
Yeah,
it. I
yeah,
wanted
yeah,
you to
yeah.
catch
I
where you were
supposed to
making
be,
that mistake.
yeah,
So
it's supposed to be times 20, not 10. Okay.
you got it. Yeah. So if you did times 10, you'd get 100. And
Mm-hmm.
then, yeah. Good. Good catch. All right. So let me go down to the multi-step problem. I think I have it here. Yeah. It's this Dilantin question. So I've done this a couple of times now, so I'll create another one just since this is our last version of it. So I'm going to change this up. Let's make this be, let's see. I think I did 7.5 already. Let's do 2.5. Leave that alone. We'll make this be 500 milligrams per milliliter. And we'll make this person be 125 pounds. Let me just see, 215, 177, 127. Oh, we already got one that was close to 125. So let's do 185. That might be good. Sorry, don't worry, I'll let you do that. I'm trying to create a variety of questions with doing that. Let's actually make this be, I'm gonna make this 25. All right, so I'm just gonna go up to the previous one and then I'll have you do this one on your own. So if you're ready to do it, go ahead and do it. Just so you know, the one that I'm gonna ask you to do is 25 milligrams per kilogram. Patient weight is 192 and your available is 500 milligrams per milliliter. So if you're going to do that, just make sure you have all the correct data. So when you're doing this, all this question is asking you to do is 2 steps. Step 1 is convert the patient's weight in pounds to kilograms. And then step 2, apply, or once you've done that, then you're going to multiply by the loading dose, so whatever the milligram kilogram is. So I gave you a couple different options and scenarios, and then you're going to solve for how many milliliters to administer. And you already know how to solve for milliliters. You either do that using desired over have, ordered over available, or using dimensional analysis. And so in this scenario, I took 215 divided by 2.2, and I got 97.7. I rounded to the nearest tenth. I multiplied by 10 and I got 977. Then I divided by 250 because my order said 250 milligrams per milliliter. And I get an answer of 3.9 milliliters is how much I would administer. So now I'm going to ask you to go ahead and make sure you can solve and answer this question right here. So I'll do the same thing, just put it into the chat once you get an answer, and then I'll confirm what I have, and I'll leave the original setup here as well, just so you have it as a to look at. All right. You should get, with this question, you should get an answer of 4.4 milliliters. All right, so I'm gonna just open up, any questions you have regarding the 130 tests. Like I said, we covered the stuff that's new, but if you want to review any of the old things, just let me know what question or question type that you want to review, and I'll go up to it and then we'll review it. If you don't have any other questions, then you're free to go. You don't have to stick around, but I'm here if you have any other questions. Just ask.
What I did, I I converted the 192 pounds to kg, which is 87. Then I now that 87 times
Well,
the
hold on. It wouldn't be 87. You want to round that number to the nearest tenth.
okay, let me see. What I got was 7.3. Let me double check what I did. 87.27.
So what would that be to the nearest tenth?
87.3.
You got it. So use that number for the rest of your calculations. But go ahead.
Okay, so the 87.3 times 25. And maybe, yes, where did I get this 25 by the way? 25 milligram per. Did I do it right?
So far, so good. Yep.
Okay, let me double check what I got now. It is 7.3 times 25. Then that's supposed to be 2182.5. 2182.5 divided by 250.
Not 250
Oh, divided by 500. I have
because
to.
I changed it just to, again, just, and like I said, sometimes there's a delay in the video or
Mhm.
sometimes it cuts out, but I wanted you to know I did change the available. That way it gave you like a different, type, different example of this type of question.
Okay, 4.4
There you
ml.
go. Good. Okay.
What about the two? What is it? Okay, that one. Okay. So there's the 500. Okay, all right. Let me see if I can do the other one.
I think you're right. Let me just double check. So when I do this, I just take the 0.05
Change it to.
times 1,000.
Mhm.
So that way we're in micrograms. So yeah, so 500 divided by 50 would be, you said 10.
Yeah, 10 ml. That when
Yeah,
I convert the milligram to microgram, and I say 500 divided by 50 will give me 10.
you got
Okay.
it. Perfect.
So the one you taught them in the morning, in the previous time, I will be able to see it in the YouTube.
Yes, and you have access to all of this. And all this is a copy of what you should have received in your as your review packet. It might even be outdated, to be honest with you, but you should have access to all these questions as well.
How many question is that?
There's 25, but I added like extra questions through like especially for the flow rate questions. So like the first few questions are pretty standard, like what you had in 110, where you have conversion questions,
Mhm.
converting milligrams to grams, milliliters, ounces, converting pounds to kilograms, your urine or your fluid replacement volume question, which you saw last semester as well, and I worked through this as
I
well.
wasn't, I didn't join them in the last semester. That's why I'm kind of confused.
Oh, okay.
Are you able to, can I, can I put my email down?
Just email me, so I will, that way I can respond to it so you can get the information. So I'll put it in the chat here again.
Okay, where's the chat?
Because if you ask me to email you, I'm not,
No. I just wanted, guys, I
yeah,
wanted to take
I'll
your
forget.
email.
That's all I was gonna say. So
Yeah, I'll, I'll take your email.